I just come across this video. Right. You know what I've been watching on the Sat-24 rain radar, the IceCat signature, which is an energy signature caused by microwave technology, which coincided with this that's appeared on this video that I'm watching as the sun's energies hitting the same area. So you've got IceCat on the edge of where this anomaly is happening. And at Ascension Islands and the Azores, where it's centering, is a massive energy increase. We know NEXRAD radars attract lightning storms. So is the technology they're now using attracting solar storms? Just a little question I had that popped into my head. It's all energy related, if you see what I mean. Well, I've got some washing to do, so I've had enough rest for today. Roxy's getting stuck into meat and kibbles, and she's got another big bowl there of meat and tripe. And at the moment she seems to be going for the kibbles bit. So she's mixing it up herself. I don't need to mix it up for her. I just give her a bowl of meat and a bowl of kibbles, and she eats what she wants to eat when she wants to eat it. But as long as she eats 2 lots of meat a day now, she starts showing a bit more growth and bulk out a bit. Time for her to grow up, innit? She's still at the last of the puppy stage. Look. She's got the run of the place, so she's quite happy. Once she's satisfied, she come wandering back in again. Yeah, so we got that. Quite an interesting one. Let's have a nose.
It's split almost into 2 now. It's gotten bigger. It's taken over the whole southern South America continent.
I'll show you why it piques my attention.
This way, it's actually reaching Africa now too, and it kind of looks like that, you know, like kind of like that. So you see that, right?
Right, watch how it moves. It's in the Indian Ocean.
And it'll change position. Why? Because the Earth's rotating. Okay?
We know they manipulate the weather up in off the California coast, affecting the jet stream. So they're using some sort of technology up there, probably based in Alaska, like IceCat is. And then you've got one down at Ascension Island. So if you imagine the same line around the planet, there's probably one down in that area, probably Hawaii or something.
Comfortable enough trying to
see what I mean?
Exactly what this thing is trying to show us. Okay.
And it's lighting up the solar storms.
We actually took a pretty decent. And what's interesting about that, you know what's right here? That's the South Atlantic anomaly.
Which affects the weather.
That means that the magnetics and stuff down here, guys, is weaker. It's weaker, and it's oddly shaped.
And they're doing it while the magnetosphere is in a weak state. How crazy is that?
And it's split almost into 2 now. It's gotten bigger. It's taken over the whole southern South America continent, And then if you go over this way, it's actually reaching Africa now too.
If you've got
And it kinda looks
LHC
like that.
running
You know,
some
like,
sort of test at the moment as well, there's
kinda
going
like
to be
that.
major
But
problems, I
it
think.
looks as though it's split in two.
Something major's happening now.
And this is hitting right there. I mean, look at that. So maybe stuff's getting in. I don't know. Maybe it's deflecting it more. It could. So, so yeah. Here is the Magnetopause models. This is the newer ones. The sun's off to the left. The ones over at ISWA are the ones that were, you know, the ones that we're all accustomed to using. But they are the older tools, and they are, you know, they're quite old. So, you know, now does that make the data over there invalid? No way it doesn't make it invalid. Because it was good enough to use back then, why isn't it good enough to use now? Because there was a lot of people back there back then using it, and now there's a lot of people saying bad things about it. So it doesn't make any sense. So if you were hanging your hat on it back then, and then, you know, and now you just like won't even look at it, I think that's a mistake. So, but anyway, you see I will say that these updated models, they do have a better visual. They probably have better data input, which will help the models to, you know, give us what's really actually going on a little bit closer to what is. But those other models can be adjusted too, guys. Okay? You know, they say, well, the new ones, they might be messing with them, you know, so we can't see stuff and all that kind of stuff. And I have no doubt in my mind that could happen. I'm dead serious. But what would stop them from changing it on the old models? It would be just as easy to do that. So that's what I'm saying. If you're going to discount one, you got to discount them both for that reason. My opinion, you know. Anyway. So, we got this right here. This is the density. And again, remember this was all white yesterday. Okay? And now we're, you know, the wind speed's slowing down, right? We're getting like 300 on the high end right now. So with slower wind speed, the particles hang around more. They're more dense. That's what's going on there. Alright? That's why we're seeing that. And actually, this right here is a little bit more of what we normally see anyway. Okay?
Give me
when it
that.
gets all white like that, that's
Give me that toy.
Not to say that it's unheard of, because it happens quite often, but it's not what our ambient conditions are. It's not what we would consider that. So, you can see when it all changed, because this one here shows it really well, because the pressure's really low, and then round about here, which would have been what time? 13:05 UTC on the 5th. Okay, just, I don't know, about an hour ago. Okay. And, you know,
I'm going to get it.
Oh,
give me
we're
that
back
toy.
to more of a normal
Give me that.
magnetopause.
Oh, I'll have it.
So, that's what happened there. Nope, this is the sun.
I'll get it.
I'm going to show you guys these flares real quick. Flares and a couple CMEs that we did see.
My toy.
So we'll look at the flares on the 131 because they show up more. They're easier to see. And they're going to come from here. I showed you one of the bigger ones yesterday.
Sorry.
That happened.
Yeah. I'll have it.
It's right here.
Sorry.
Right there. See that? Okay, then a smaller one happened, right? Then another one. Then another small one. If we went back to the graph, the solar X-ray graph, you would see a bunch of them right there. Okay? They were like bam, 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 bam. You could see it. Each little spike was a little flare. So those flares.
My toy.
We'll look at it over here on
My
the
toy.
211 to see the CMEs.
Give me it.
On the other
Give me that
spot
toy.
because it's easier
It's
to
mine.
see.
It's my toy.
So let me do
Mine.
this.
Get off. Get off. Give it off. Get off.
Right here. There's the first one. There's the second one. There's the third one. There's the fourth one. 4 little CMEs. Now, they do look as though they're coming in our direction, guys, especially the last 2. Even that last 3, I would say. So, that plasma did leave the sun. That was an ejection. Now, it's not a huge one, but this is the stuff we're talking about that's going to be, attached pretty much to the solar wind stream. We're probably not going to be able to tell much of a difference when it changes from just the solar wind to
Lay down.
the CME.
Come on.
It's going to look very similar. Now, if this was a big one, then yeah, we might have something different to talk about. But that most definitely is what you're seeing there. So we got flares, CMEs. Okay, this sunspot here is probably going to stay in front of us probably for the next week and a half. Probably right about a week, I would think, from now. But here's the 304. I'm not going to show too much of that, but this one here is what we look at when we look for filaments. Okay, so yeah, there's your flares and your CMEs. Now let's take a look at the Australian model. Shout out to Mossies. Let's let this thing load. Remember, this one's very, very simple, but it's easy to understand. You got your wind speed, and then you got your density. Notice how everything's just kind of stuck right around 295, 300. Then the proton density, the density that we talk about, has shot up to 23 right there, which is high. Higher than normal. So that's probably what we're seeing on some of these graphs right now, is that increase in density. And the speed itself looks like it is picking up, so it's probably that coronal hole stream. That's what that's pointing to, guys. Geoelectric field model, it's space weather's effect on our unnatural electrical components, basically our grid. Transformers, wires, substations, all that kind of stuff. And you can see, just like in that other graph I showed you, remember down there at the South Atlantic anomaly? This is kind of what the same thing we're kind of seeing here, okay? It's probably happening right about the same time. It is. So, it's probably the same energy. It's just hitting down there on a different graph, showing something different than what this is. Okay, this is seeds. I'm going to back that off here a little bit. 11.5 here. And so you can see these jets like kind of popping out a little bit around the occulter. Remember, this is our view. The Earth is here. Okay, looking at the sun. So let me go to the previous day, the 4th. And you've seen a couple of those CMEs pop out right here. Watch. It'll look like a little cloud. Right there. Okay? Now this is our view. Now notice you got all this debris stuff flying around right here. I'm still not sure if we're in some sort of I don't think we're in a meteor shower right now, guys. So this is very, very dirty looking as far as dirty area of space. This may be the solar flares and the CMEs reacting with the camera, and the camera, because it does this. It'll like when it gets like a big flare right in the camera, it'll look like this. The red will turn into what this looks like over here on the left. Look like white noise. But that doesn't mean that anything really big happened there. It just means it caught a flare. And that's how the camera interpreted it. But you can see jets flying out everywhere around here. And it's from that a couple CMEs and that sunspot. Okay, with this flaring. CME tracker, I talked about this in my last video. This really upsets me because, this thing hasn't updated since the 1st. We've had other CMEs. We got CMEs coming at us. Why isn't it showing us those? I know they're probably not big ones, but my gosh.
Yeah, big
okay, earthquakes. We did have another decent size one up there last year, guys. That's a 5.1.
So you're a good girl, Tail.
That's on the bigger side than what we've been seeing. We've been seeing like in the 4s up here after the big 7.6 happened like 2 weeks ago.
All nice and happy.
Plus, we're getting, you get a good idea,
Good girl.
guys, of what's going on around,
Good girl.
what's going on with earthquakes just by backing the whole picture off and just kind of looking at it and seeing how busy it looks. And you'll find yourself being able to notice things after a while, which is what I'm doing. Okay, I'm still not up to where I really should be to be able to get into anything kind of technical.
Give me the
with these
eyes, are
earthquakes,
ya?
other than to say that when we have solar wind, the earthquake chance goes up. And I've always stopped there, and I'm going to continue to stop there until I think I know this stuff well enough to do that. I don't want to do a disservice to you guys and tell you the wrong thing. So what I
You've
did
been a
there,
fidget bum.
I changed it from 2.5 to all
Yeah.
magnitudes. Watch that again. Okay.
You've been a fidget bum.
Looks pretty, kind of normal, just kind of a slow day,
Sorry,
right?
she's
Well,
wound up like a spring at the
no.
moment.
Okay, we can dive in
She's
here.
cuddling
again.
me and I'm all
These
hyper.
are areas we would
So
expect
she's
to
like
see
ready
them
to
quite
react
often
at our
anyway,
moment's notice.
but maybe not to this
She can sense the
amount.
energy.
This is probably fracking, guys. Okay. Again, up here in Alaska, I asked Ricky if that was kind of normal up that way. She said it was, because I wasn't too familiar with that part of it, and I just had that question. I wasn't sure. So she said it's pretty normal. I mean, it's not like it happens every day or anything, but it's not like extremely rare. Okay. Now watch this. 7 days, all magnitudes. Look at that. That's the last week. You can definitely see where it's flaring. Now this is something I found interesting too. All these right here, they're all about the same size. Even down through here. These are all in like mid-range.
Yeah.
Okay?
Got it out now?
I find that really interesting.
Bit of
There's a big
trap
one that
wind,
happens
was
over
it?
here in Greece.
Right, you let your
We
dinner
had,
go down
this
then.
weird one over here in Russia, and a couple weird ones over here in Alaska. Not Alaska, but Canada.
Right, it's only a butt.
Kind of strange. But, sometimes we do get earthquakes, guys, in crazy
She's
places.
looking a bit freaked out with herself now.
And every time it does mean something, but it doesn't have to necessarily mean something catastrophic. Okay? Obviously, we're all still here, and that one happened, and nothing, you know what I mean? Helioplots, I'm not going to go down through here because we're not seeing much here. These are the seismic
Yeah, I
areas
opt
that,
not to
we
look
have.
up that sort of data myself on American
I started showing
sites
these when we got
because
that 7.6 up from
if you
Alaska,
log on
'cause
to an
it
American
really rang our bell
website,
pretty good.
especially a US
Everything
government
turned
one
black on
or
these.
funded,
Okay,
you're
here's that
liable to
flare.
have all your computer
Let me
spied on.
do it like this for you guys. It's going to show you the
So
flare.
just
back to
don't
back
on
to back to
principle.
back. See it?
Got no
So
reason
that
to
was a
spy
C-
then, have
I
they?
think it was a C7 it came in as. Let's look.
But if someone wants to show me it, I'll
Yeah,
quite
came in
happily
as
watch it.
C7 class. All
It's all
right.
energy.